All right, so this video is going to focus on how to factor a sum of cubes example. So you're either given an example where you're told that it is the sum of cubes, or maybe you're trying to determine, hey, is it the sum of cubes? Is this the proper technique that I'm using? So again, when it comes to factoring, because there are so many different factoring techniques out there, it is very important that you understand what technique you are using to factor depending on what given example you have, right? So there's all sorts of different examples out there. I mean, you could use a different factoring technique with all these different kinds of examples. So trying to figure out what current technique you're using for this problem, that's probably the most frustrating thing about factoring, just because there is so much out there. But we're focusing on the sum of cubes. And when it comes to the sum of cubes, there are three nice little criteria that we can use to make sure, hey, I do know we're using the sum of cubes for this example, we've got this. All right, so when it comes to the sum of cubes, the most obvious thing is the fact that you have two terms in your example, 1, 2. The second thing is that they're both positive terms. You have that plus sign in between them, right? So this term's positive, this term's positive. All right, that's step 2. Step 3 is that they're both perfect cubes. So remember, a perfect cube is the same thing times the same thing times the same thing to get that. So we have two terms, right? And we need to figure out, are both of them a sum of cubes? Now, since our lovely formula over here, this is the formula for sum of cubes. It uses x's and y's here. So what I'm going to do is I'm going to label these x and y. Now our x is going to be what times what times what is this first term. So what times what gives me a 125 t to the 6. Starting with the number 125. So what times what is 125? Is it 2 times 2 times 2? 3 times 3 times 3? 4 times 4 times 4. And unless you're comfortable with the numbers, maybe you can look at that number and you automatically know what it is. If not, maybe use a calculator and do some multiplication until you can figure out what it is. Now for this one here, 5 times 5 times 5 happens to be 125. But then we need to look at the t to the 6 and think, well, what times what is t to the 6? Is it t times t times t, t squared times t squared times t squared, and so on. Now, for this one here, it actually is the t squared, right? T squared times t squared is t to the 6, right? So 5t squared is going to be my x, right? Since if I take that to itself, I multiply to itself 3 times, it gives me 125t to the 6. Do the same thing for your y. Your y is what times what times what is 216g cubed. So starting with the number 216, right? So we need to figure out what's going to multiply to get that. Well, it's definitely bigger than the 125, so it has to be bigger than a 5. So maybe start with 6. Is 6 times 6 times 6? 7 times 7 times 7. And I actually believe 6 times 6 times 6 is 216. And then looking at g cubed, the only way to get g cubed is a g times a g times a g. So for here, we have 6g. So those are our x and our y's. After we figure out what these two values are, it's a matter of plugging into this formula here and just seeing, maybe doing a little bit of simplification for it. Starting with our first factor here, x plus y. So let's see, our x plus our y, so that would give us a 5t squared plus 6g. So that's exactly what I'm going to put in, 5t squared plus 6g. Then we have our trinomial. So the first thing we have here is an x squared. So square your x. 5t squared times 5t squared. Right? 5 times 5 is 25. And t squared times t squared is t to the 4th. Minus. That minus is part of the formula. Now we need to do x times y. So 5t squared times 6g. Right? Our x times our y. 5 times 6 is 30. T squared times g is t squared g. Plus, the last thing we have there is our y squared. So let's figure that out. Our y is a 6g, so that's going to mean 6g times 6g. 6 times 6 is 36, and g times g is g squared. This nice, big, lovely thing right over here is our final answer when it comes to this example here. So again, this is the sum of cubes. It does have to fit those 3 criteria. You absolutely need this formula, whether you have it in your notes, whether you have it memorized, kind of just depends, in order to figure out your x and your y to plug into it. Also, do remember when it comes to any factoring example, regardless what the technique is, you can always check your answer by multiplying back out in the end. So you can distribute this, and you should get left with your original problem when you do so.